Walk you through a quick little background on what we do as a company and what's kind of led us to our current focus on interoperability between protocols. But maybe we'll step back a little bit. I'll tell you the track record of our team, our group. We've been focusing pretty heavily over the last three and a half years at this point, starting with some time working at Deloitte, where I started kind of the first blockchain team focused on the enterprise market and any of the large global consulting firms. Really focusing on why this technology was going to become the next evolution of enterprise infrastructure. Over the course of the last few years, this eventually got formalized into our role today in the Enterprise Ethereum Alliance. The standardization of how do you use technologies like Ethereum, protocols like Ethereum, to rebuild distributed infrastructures for our industries, for our banks, for our insurance companies, et cetera, et cetera. What we realized over the course of that time, that those years of development and thinking through that problem statement, is that we were kind of creating a whole new set of problems. And we identified this in the public blockchain kind of ecosystem, and we were starting more and more to identify this in the kind of private enterprise blockchain ecosystem. So before I get there, I'll walk you through what we're working on today. We're referring to as the third generation of blockchain networks. Obviously, that tends to imply that there are two previous generations that you'll be very familiar with. One obvious was the iterations around Bitcoin, the altcoin ecosystem that happened after Bitcoin in 2009, technologies that kind of focused on reapplying that concept into the enterprise market, like Ripple and others. These are really protocols designed to move value peer-to-peer between different participants in an industry. Pretty simple, pretty elegant, and very important technologies. After that, we saw kind of the creation of these second-generation blockchains focused on how do you put business logic and processes on top of a blockchain so that you could automate different things, remove intermediaries, and start to create smart contracts and smart agreements between different counterparties. Again, we saw the evolution of Ethereum, and in parallel to that, we saw the evolution of all these other technologies that were focused more on the enterprise market. Technologies like Hyperledger and what we're working on at the Enterprise Ethereum Alliance, and Corda being developed by R3, and a whole bunch of these protocols focused on this kind of second generation. What we've seen even more recently is this hypergrowth of blockchain protocols. If you follow the ICO market, you'll probably notice that probably on a monthly basis, you're hearing about some sort of new protocol. Whether it's Tezos, EOS, IOTA, private networks like Chain, Dfinity, Ethereum Classic. You guys know these brands. All of them trying to solve something in a slightly unique way. And that's what really excites us about this industry, is that we're in this time where there's capital available for these massive global experiments to take place, each of which are hypothesizing and testing out different theories. And they all have something really unique to offer, but the one thing that they're missing is interoperability between them. So as we see this hypergrowth in blockchain protocols on the enterprise side and the public side, the new problem that we are going to have to face in the infrastructure of our ecosystem is interoperability. So what haven't we solved with these second generation blockchains? Obviously, interoperability is intended to solve the problem of isolation. The fact that if you operate anything on one blockchain or another, there is no way for these transactions to interconnect without having to rely on some sort of centralized intermediary. So the irony of our decentralized ecosystem is that we've created new types of centralized intermediaries to sit at the intersection of our decentralized technologies. Exchanges sitting at the intersection of Bitcoin and Ethereum and Litecoin and others. In the enterprise market, having to centralize somebody who pulls in data from kind of the outside world to actually facilitate logic on top of a blockchain. So isolation is a big problem. Scalability is an enormous problem that we're seeing increasingly in the public blockchain space, where the more we hypothesize what types of business models we can put on top of technologies like Ethereum or Bitcoin, the more we realize that there are some fundamental limitations of these technologies as single networks. So if we don't want them to be operating as single networks and we want to achieve this performance that is necessary for the entire world to be decentralized, we're going to have to think differently about this architecture. And from our perspective, that means a future with many, many blockchains. We've seen today probably hundreds of blockchains in real existence and real use. Our hypothesis is that number will grow to thousands, tens of thousands, hundreds of thousands, and maybe millions of blockchains that are built based on different industries, built based on different geographies, and built for different purposes. And now we need to create a solution that allows them to connect to each other. That's what we're building with Aion. Aion essentially is a system that allows you to do three fundamental things. One is this concept of federating transactions across different blockchains. The ability for a transaction on one blockchain to be autonomously triggered as a result of a transaction on another blockchain, without the reliance on a centralized intermediary to kind of translate or pass that message along. The next thing is this idea of scale. Today, if you build a blockchain application, you build it on a single blockchain. You build a dApp on Ethereum, it draws its logic from the Ethereum blockchain, it triggers outputs inside the Ethereum blockchain. You don't have a decentralized way to create an application that is natively resident on many blockchains without centralizing its processes. And finally, this idea of creating spokes in a hub and spoke model that essentially would say, if you need to spin up a new blockchain for a particular period of time, a particular specific sub-use case, it would be very, very easy to create these spoke blockchains that kind of connect back into the hub network. Aion is designed as what we call a multi-tiered blockchain architecture. Multi-tiered implying that, in this, whether you lay it out as a tree architecture or you lay it out as kind of like a hub and spoke model, one blockchain connects to another with a protocol we call the bridge. The bridge is a decentralized communication protocol that would sit at the intersection of two networks. The ability for nodes on one network to be able to witness transactions on another network, agree as a bridge that that transaction has taken place, and signal the following network that it has taken place, to be able to kind of have that triggering of transactions. What we can do beyond this kind of second-tier network is we can start to allow other networks to become connecting networks themselves, where you use blockchains in this context as essentially routers that would allow other blockchains to connect with them, witness transactions, and pass them along. What we noticed when we started researching this is that there have been a couple of projects over the last couple of years solving this idea of blockchains witnessing each other's transactions. Probably the most commonly known one is a project called BTC Relay that was developed by Consensus based out of New York. BTC Relay was a smart contract on the Ethereum blockchain that could witness and confirm transactions on the Bitcoin blockchain. It would maintain essentially a state of the Bitcoin blockchain inside its smart contract on Ethereum. They had proven a pretty elegant way to witness transactions across these two chains. Our challenge is that as we scale the number of blockchains in existence, it's not feasible for every blockchain to constantly be aware of every other blockchain. Meaning, if we go to thousands and tens of thousands of blockchains, there's a scaling challenge with that model. So instead of a direct blockchain-to-blockchain connection, we create an intermediary chain, a chain that acts as a router. We're building a new blockchain called Aion 1 that essentially is a decentralized routing system that other blockchains can connect into, allow for transactions to operate not only within their chain, but also the creation of what we call interchain transactions. I'll skip through this kind of quickly. We can make these slides available if you're interested. One of the things that we fundamentally wanted to solve in the creation of this was how do we create a token system that would enable and incentivize people to connect their networks to each other. A token system that could be used to build bridges, a token system that could be used to monetize the flow of data between different blockchains, and a token system that was not restricted to a single blockchain. So we're creating this system on the basis of, as many people are working on today, an ERC20 standard token on top of the Ethereum blockchain. But native to the design of our token is this ability for that token to essentially teleport from one blockchain to another in kind of a burn and mint function, so that as we prove on one network that a token has been burnt, then we can instantaneously recreate that token on another network, so that we're not restricting our token systems to single blockchains. So this is what is already kind of fundamentally built into the design of our token, and what we'd like to be able to make available to kind of the creation of other tokens, so that when people build their token economies, they're not beholden to a single network, but they can scale across a multitude of networks. The role of the token inside of our ecosystem, four kind of fundamental functionalities and a few more that we're still in the process of researching. One is this idea of main chain operations that you'd all be familiar with. This is the process of participating in consensus, staking tokens into that model, and paying for transaction fees on the main chain. The second is using the token to actually access computing resources on a distributed virtual machine, not too dissimilar to how Ethereum charges gas. So the ability to kind of charge for computational power so that applications can be executed. When you build an application on top of Aion 1, kind of core design component of this that is different than other blockchains is you can build an application that pulls its logic from other blockchains rather than only pulling its logic from that one single blockchain. Thirdly, creating interchain bridges. Our token is a requirement and a necessity when you create a bridge and instantiate a bridge between Aion 1 and any other blockchain to stake tokens into a bridge registry contract that essentially allows you to create that bridge and start monetizing the flow of data on top of that bridge. These bridges are groups of nodes that essentially have a lightweight consensus process that allows them to witness transactions and pass them on. And finally, we use our token to create new customized participating blockchains. So that if a company or any type of group of developers or organization comes in with a use case for a new network that has a new group of counterparties that might have some unique requirements around governance, regulatory oversight, different performance thresholds, we want the ability to build a blockchain to be a simple function call on our network. The ability to kind of define some parameters and a new blockchain be created with those parameters kind of core in their design. So that'll be a function that also requires kind of the use of tokens. Two other functions that we're still kind of in the middle of researching that we'll spend some more time on publishing over the next few months is this idea of using the Aion token in kind of a gold-backed standard model so that you can use one token to back the supply and value of another token system. And the other is using the Aion network essentially as a mechanism to share the security of one decentralized network across many decentralized networks. So that if you have kind of less decentralized systems, you can still kind of peg them to more decentralized systems to create that kind of integrity in the immutability of the data. We're in the process of kind of finalizing our alpha release of what we call like build your own participating blockchain. We'll be releasing this along with our token next week. And this will be a function that users of the ERC20 token that we're providing to the public will essentially be able to kind of call that function and create their own participating blockchains with some unique characteristics that'll be natively designed to connect back into the Aion ecosystem. A little bit about our team. We're Toronto-based. This slide week by week becomes outdated because we're growing pretty quickly right now. We've got a booth here if you want to come find out more about us. We're all based in Toronto. We've been doing this for as a company, we've been doing this for 1.5 years. As a founding team, we've been doing this for about 3.5 years, working on this problem of the enterprise market. Our role in the Enterprise Ethereum Alliance is not only do I sit on the board of directors, but we're also very involved in the technical steering committee. And what we see fundamentally beyond the technical solution of connecting blockchains to each other is, we're looking to that future state where the mainstream enterprise market really starts to adopt this technology in a meaningful way. And we're positioning Aion to essentially create that bridge between what used to be two ends of a spectrum, the private blockchain enterprise market and the public blockchain market. How do we allow for this ecosystem and this infrastructure to look seamless to the end user? Whether you're operating transactions on a private network backed by a group of banks in the United States or a public network like Ethereum or something that hasn't yet been invented, how can these transactions flow back and forth without the user even knowing that there's different layers of infrastructure? And this is not all that dissimilar from how we've kind of fundamentally built the internet over the course of the last few decades with these layers of different kind of private and public networks that all share a common communication protocol that allows this data to kind of flow freely between them. So, love for you to come find out more about us. The project is called Aion. The team behind it is the company at Nuco. You can find out more about us at aion.network, and please feel free to come find us later in the day. We'd be happy to answer any questions. Thank you.